don't get that on recording, that's okay. I'm okay with that. Okay. Where was I? So we're on a width of 2. That's all we've gotten to at this point. So again, you don't have to do those little interval pieces. You also don't have to do a table, but I'm going to do one anyway. So essentially, while we might not use them all, why don't I go ahead and find the y values at all of these points? So I could have circled 0 and 2 again, but let's just. So I'm looking at -2, 0, 2, and 4. So let me go ahead and find the y values for all of those. I might not need all of them, but find them anyway. Well, actually, we will need both of them because we're asked for both sides. But anyway, so plug them into the function. So -2 cubed is -8, -1 is -9. 0 cubed is 0, -1 is -1. 2 cubed is 8, -1 is 7. 4 cubed is 64, -1 is 63. So now we're asked for both the right and the left-hand sum. Let's work with the right-hand sum first. So now the widths of all of our rectangles is 2, and that's going to be true in either case. Both of these sums are going to have width of 2. So essentially, you can either write 2 times plus 2 times plus 2 times, or you can write the 2 on the outside if you're lazy. So I'm going to do that. So I'm going to write my width on the outside and then just sum up all of my heights, all my lengths, whichever you prefer to call them.
Can you please go over how you got -9, -1, and 7 and 63 again?
So I'm given the function x cubed minus 1. So I'm taking all of those x values and plugging them in. So 0 cubed minus 1, 2 cubed minus 1, and 4 cubed minus 1. So I'm just using the function that they gave me in the original problem.
Okay, and the x values came from where?
So those came from the 2 of them I'm kind of given. So I need to go between -2 and 4, but I need to break it up into 3 pieces. So if I'm breaking the distance from -2 to 4, which is a distance of 6, if I'm breaking that up into 3 pieces, each of my pieces is going to have a distance of 2. So let me start at -2 and break it up every 2 numbers. So I'm going to go from -2 to 0, that's a distance of 2. And then from 0 to 2 is a distance of 2, and then 2 to 4. So I'm essentially taking the 2 numbers that I'm given, which is a total distance of 6, breaking it up into 3 pieces. And so the 0 and the +2 come from kind of where I need to break that up to get me 3 pieces. Does that make any sense?
Yeah, that made sense. Thank you.
Ooh. Let me try to unhighlight some of these. So what am I doing? Right-hand side sum. That means that the lengths are going to come from the y values of the right-hand side of these kind of intervals that we're breaking it up into. So we're going to use -1, 7, and 63 in this case. So we have -1 plus 7 plus 63. So again, you could do this as 2 times -1 plus 2 times 7 plus 2 times 63, or you can put the 2 on the outside. This gives you 138. Questions, concerns on how I found that? Okay. Can this go away? Go away, little thing. So Sarah, so right here, I have the 3 intervals that I'm working over because I'm breaking it up into 3 rectangles. I'm going from -2 to 0, 0 to 2, and 2 to 4. So what the right-hand sum does is it says, take the interval you're looking over. So the first one we're looking over is -2 to 0, and use the right-hand endpoint for your y value. So we're not using the -9 because that comes from the -2, which was a left endpoint. So we're only using the values from the right endpoints of these intervals. So that's why we're only using the values at 0, 2, and 4. Whereas, let me do the next one and maybe it'll make a bit more sense also. When we want to do the left-hand side, we're still using the same intervals. It's still from -2 to 0, 0 to 2, and 2 to 4. But now we're using the y values from the left endpoints. So from -2, 0, and 2. The widths of each interval is still 2, so that just gets there. So now for the right-hand side sum, I'm using the values at -2, 0, and +2. So this time I'm going to use the -9, but not the 63. Because I'm only using the ones from the left side of the intervals. Also, you can triple check yourself. If you're asked to do 3 subintervals, you should only be summing 3 things together. You're summing more than 3 things, you're using more than that many intervals. Well, or you're just messing up anyway, you're doing it wrong, no matter what you're thinking about. So here, since we only have 3 rectangles, we only want to sum up 3 things. But the things that we're summing are depending on, are we looking at the right side or the left side of the rectangle that we're forming? Are we going up to the left side of the function or the right side of the function? This gives you something. It's something. It's like way smaller than the other one because it doesn't have the 63 in it. Next. Don't panic that it's negative. If you even thought to panic because it was negative. So yeah. So the numbers we use depend on what kind of handed sum you're using, if you will. Sarah, did that make sense, or do you have any more questions, or does anybody else have any more questions on that one?
I have one more. So -2 and 0, the 2 and the 0, and the 2 and the 4 that you got, where the star you got, the star you put next to it. How did you get those?
So you're always going to be given the total interval that you want to work over. So the total interval we want to work over here is -2 to 4. We were given that in the original problem. And then you're also going to be told one of 2 things. You're either going to be told how many rectangles or what the width of the rectangles is. To find the other value, you're going to take the total distance you're working over divided by the value that you're given to find the thing you don't have. So if you're given the amount of rectangles, you'll be finding the width, and if you're given the width, you'll be finding the amount of rectangles. So if we're going between -2 and 4, there's a total distance of 6, because there's a total distance of 6 between those 2 numbers. Essentially, if you take your end number minus the beginning number, so 4 minus -2 gets me 6, if you're having trouble seeing why it's a 6. So we want to break that 6 into 3, that distance of 6 into 3 subintervals, because that's what we're told to do. So if we want to break a distance of 6 into 3 pieces, each piece is going to have a distance of 2, because you still have to span that distance of 6. So if you need to span a distance of 6 in 3 pieces, each of the pieces needs to have a distance of 2. So if we're starting at -2 and kind of hopping over a distance of 2 each time, if we start at -2, if we add 2 to that, we get 0. If we start at 0 and we add 2 to that, we get 2. And if we start at 2 and add that 2 to that, you get 4. And we were supposed to stop at 4, so we stop. So these things that I got were essentially breaking it up into the pieces that I need to break it into. Since I'm breaking it up at 0 and 2, and I'm starting at -2 and 4, I get -2 to 0, 0 to 2, and 2 to 4. Did that make sense?
Yeah, that makes sense. Thank you.
Any more questions?
I have one quick question. So if we were given the width, we would just take the distance we find and then divide it by the width to find the rectangles?
So yeah, say we were given, to say the width was 3 instead of the number of rectangles, this would mean that the number of rectangles would be 2 if we were using the exact same problem, but a width of 3. So then the intervals you would be working over is 0, nope. -2 to -2 plus 3 is 1, and 1 plus 3 is 4, and we're supposed to stop at 4. So yeah, whatever you're given, if you divide the total distance by that, it'll give you the other thing that you don't have. So if you're given the width, it'll give you the number of rectangles, vice versa. So if the width was 3, we get 2 rectangles, so we would just want to break it up into 2 pieces. So we would get that. Hopefully that makes sense.
Yes, thank you.
Lauren, will the distance always be even? The reason I'm thinking so much, so in general, it doesn't have to be. In terms of questions hesitate slightly as I am slightly, well then get better network quality, USC. Anyway, sorry, let me wait until that goes away because some people can't hear me when that's up. Go away, bad network quality. Go away. It actually, the whole thing went away. Still sharing my screen? Yeah, okay. Well, hopefully people can hear me. The only reason I hesitate is because of Wiley. I don't think Wiley does have any odd distances either, but that's the only place where it could possibly come up. If I'm asking you a question, I'm going to make it an even distance because I know breaking it up into pieces where you have to like find, you know, x equals 1/2 and x equals whatever is going to be gross. But I usually always ask an even distance. In general, it doesn't have to be. It can be whatever it needs to be. But anyway. So next one. Wow, that really got down there. So here we're just finding a left-hand sum, but now we're doing two different situations with the amount of subintervals. So in this first one, so we're going over 0 to 30. So the total distance is 30. So in part A, if we want 3 subintervals, 30 divided by 3 means that the width is going to be 10. That's a really bad arrow. And then let me just find it because I'm doing it right now. 30 divided by 6 subintervals will give us a width of 5. So for the first one, if our width is 10 and we're starting at 0, we're going to break it up at essentially multiples of 10. So we're going to be going from 0 to 10, and then 10 to 20, and then 20 to 30. So the number of subintervals should be the number of intervals you write down if you decide to write down the subintervals. Again, you don't have to write them down, but I think they're kind of nice. We're asked for a left-hand sum here. So we're going to be using the values at 0, 10, and 20, and just those values. So the table has too many values for this part of the question. So we only care about 0. Why is it all the way over there? 10 and 20. I'm going to box 30 since it was part of our choices, but the only ones we're actually using are 10, 1, and 7, because those are our left side. Our width is 10, so of course, again, you can do 10 times the one thing plus 10 times the second plus 10 times the third, but I'm too lazy for that. The length at 0 is also going to be 10. The length at 10 is 1, and the length at 20 is 7. Accidentally erased a value from the last time I wrote down this table, so now my answer is wrong. 180. I could have been able to do that in my head. That turns out to be, oh my god. Anyway. So this is the width, and these are the lengths from the y values at left end points. And the left end points in this case are 0, 10, and 20. Okay. Questions and answers. All right, so then 6 subintervals. We're going from 0 to 5, 5 to 10, 10 to 15. If you want me to not be lazy, I can write them all out, but I'm feeling lazy. It would go all the way up to 25 to 30. If you want me to write them all out, let me know. I guess I only missed 2 of them, 15 to 20 and 20 to 25. But we're still finding a left-hand sum, so we're going to want the y values at 0, 5, 10, 15, 20, and 25. Essentially the first bits of this and not the last number. Because we do want to use the whole, well, almost the whole entire table in this case. So our width is 5. add up our heights, we'd have 10 plus 5 plus 1 plus 2 plus 7 plus 15. Whoops. I don't know what that is. $200. I think, if I added it up correctly. Questions, concerns? This warm-up was a long one. Okay, the one last thing I want to remind you of before we do notes for like a hot second and then take our quiz is if you're asked to find both of the sided sums, if you will, remember that you can also find a better estimate by averaging the two. So if I asked you to find the best estimate, once it catches up with me, there we go. If I'm asking you to find the best estimate down in this right corner, you would take that left hand and add it to the right hand and divide by 2, average the two numbers, and you can get a better estimate that way, which would be 66. Now notice, the reason those numbers are also very different is because we're not using a lot of subintervals. So the less subintervals you use, the worse your estimation. So notice there's a huge gap between -6 and 138. So those are two very bad estimations, but if we average them together, we get a better one. Questions, concerns? Yeah, I want to start the notes at least. We're not going to get very far. So I'll wait like 5 more seconds in case someone else has a question. Okay. Where the heck did the thing go? Guess I gotta jump back here. So jumping over to our new set of notes really quick. Again, we're not going to get very far, but we'll get the general idea started. So we're in 6.2 and 6.3. So we're going to jump around a little bit. I know we were just in chapter 5 and now we're in chapter 6. We're going to do these two sections, then jump back to chapter 5, and then jump back to chapter 6. But we're going to jump over here really quick. So we have this theorem called the fundamental theorem of calculus. Now we're going to talk about that in a bit more detail later, but I at least need to tell you what it says. So it says if f prime, and it's a capital F on purpose, is continuous on some interval a to b, then the integral from a to b, and remember that integral we learned in 5.2 is just the notation to essentially say the area underneath of that function. It was that scary limit definition of those Riemann sums. So essentially that means that the definite integral of the derivative gives the total change in the function. And again, we're going to talk about it as total change a bit more later. But if you look at this, notice that the thing that's inside the integral, the integrand, is a derivative, and the thing on the right is a regular function. So if we can find some equation, some function, such that its derivative is the integrand, we can actually calculate these by hand. Like if I can actually find that original function from the derivative, I'd be able to calculate that by hand. So I want you to think about the function 2x. I'm going to give you like 5 seconds to think about it. I want you to try to think of a function whose derivative is 2x. So can you give me that's it. Its derivative is 2x. Yeah? Yeah. So one such function that could do that is x squared, because if you take the derivative of x squared, you get 2x. That's what we're kind of going backwards now. Can anyone give me another one? What do you mean another one? Can anyone think of another one? I'll give like 5 seconds. I'm gonna blow your minds. What about x squared plus 1? The derivative of that is x squared, right? What about x squared minus 576? Derivative of that's x squared, right? Because remember, the derivative of a constant is 0. So technically, what we're going to say is we're going to say that x squared plus c, where c is going to be a constant, is going to be called the family of antiderivatives. So we just left derivatives, and now we're going to talk about antiderivatives. So we're going to do it. Let's get through this next example in the next definition, first example. That's as far as we'll get. But this is essentially what we're building up to now, is we're essentially going backwards. But when we go backwards, we need to realize that we can always pick up a constant, because if you take a derivative, the constant drops. So you always kind of need to keep that in mind by tacking on a plus c. So definition: the indefinite integral is the family of antiderivatives of a function. So if we have the integral of f of x dx, this is defined to be, now we use capital F to kind of denote the antiderivative. So we don't have prime notation here. We kind of just use the capital letter to denote we're going backwards. Notice I have no bounds on that integral. That's okay, and that's actually specifically what an indefinite integral is. We'll talk about a definite integral, which is the one with bounds, later. So essentially we have these two types of integrals. We have the ones with bounds and the ones without bounds. And we'll be working with both a lot more in the next couple of days. The one with bounds is a number. And we'll figure out how to find that number. Well, you know how to do it in a calculator if your calculator can handle that. And then the one without bounds is a family of functions. So it's not actually a set value, it's like an equation. So we're going to do this first tiny little example in a second, because people are still scribbling. And then we'll take our quiz. So say I want to determine which of the function or functions is an antiderivative of 8x cubed. One way you can do that is you can take the supposed antiderivative and take its derivative, okay? The derivative of the antiderivative should be what you started with. So if we take the derivatives of these choices, we want to try to get 8x cubed. So what's the derivative of this capital F? Well, it's power rule. Bring the power down, subtract 1 from the power. Still got to think about derivatives a little bit. So what am I writing? Lord almighty. 48x. 48x is not 8x cubed. So that ain't it. What about the derivative of this g? If we bring the power down, 8 times 4 is 32. Subtract 1 from the power. Well, now we've got x cubed, but we don't have 8. So that ain't it. And what about this one? Well, the other two didn't work. Bring the power down. 2 times 4 is 8x cubed. Is 8x cubed 8x cubed? Yeah. So here the correct antiderivative would be, well, a correct antiderivative would be 2x to the 4th. You could also have 2x to the 4th plus absolutely any number you can think of. But in this case, out of those 3 choices, that third one was the only option to be an antiderivative. We'll talk about that a lot more on Friday. That's the general idea. We started going forwards and now we've got to go backwards. Let me go ahead and stop the recording and I will get y'all off the big screen as well.